Today we're moving on to page 30, 76 to 97 odd. I said 76 and I wrote 79. I told you I was magic. Yeah, 77. Wait, maybe it is an odd. Let me look. Page 30, 76. Oh, but skip 83. There's a note that says skip number 83. So it should be 77 to 97, and then X is not allowed to be 83. How does that make you feel? Okay, so in 77 and 78, refer to the following. Research indicates that monthly profit for widgets are us is modeled by that function. Find the break-even point. What does that mean? Find the roots. Piece of cake. 79. In response to economic conditions, a local business explores the effect of a price increase on weekly profit. The function, -5 times x plus 3 times x minus 24, models the effect that a price increase of X dollars on a bottle of wine will have on the profit P measured in dollars. What is the smallest price increase that will produce a weekly profit of $4.60? So the idea behind that one is the cost. So whatever the wine bottle costs right now, if you increase the price for a while, that will increase the profits, but eventually you'll increase it to a point where it will start, nobody's going to buy it. And then you'll end up losing money. So whatever that number was, 460. So wherever the graph is, 460 is probably going to be hit twice. So it wants the smallest X value that creates a price increase up to $460. How would you do that? You could graph it. What if you graph it and the answers aren't very nice? Well, let's go back. If you graph it, how would you find the answer? Not that we don't want the zeros. We want to know where does y equal 460, and that's a little bit harder than you might think. You could do trace and try a number and try a number and keep trying numbers until you get 460. Is there an easier way? You can put 460 into the equation. How? Say that again, Aaron. Nope. Well, I mean, okay. So you could say, I guess I see what you're saying. 460 equals whatever the equation is. So you would need, what is it, -5 times, you would need to multiply these together, distribute that out, and then bring in the -5, and then subtract over the 460, and then solve it. Or, because in order to solve a quadratic, it has to equal 0. No. We want, so whatever the roots are, and I don't know what the roots are. Whatever the roots are don't really matter here. We want to know what the X value is when the graph is up at 460. There is a graphical way to do it. We just haven't gotten that far yet. I mean, we haven't talked about it today. So you could set the equation equal to 460. And then multiply the equation together and subtract 460 and try to factor it or use the quadratic formula or whatever. But there's a much easier way. Graphically. How would you do this with the graph? There's no way to trace a y value. So to find this point, we would keep plugging in random x's until I ended up with 460. And especially if the answer is irrational, you're going to be trying a bunch of decimals until you get there. But we can change the graph so that it is very easy. Make it so 460 becomes the x-axis. How do you do that? You need to change the equation. How much do we need to change the equation by? We need to drop it down 460. So you take the graph there and drop it down so that this point now becomes a root. How much do I need to drop it in order to get it there? 460. So you take the equation that you have and just subtract 460 from it. And now you alter the quadratic so the answer you're looking for becomes the root, which makes it a lot easier to solve, which essentially is what Aaron was doing algebraically, right? But we don't have an equation here. We have a series of factors that we would need to multiply together. So normally all you do is subtract 460 over here and refactor it, but this is not in a very usable form. Right now it's negative 5 times x plus 3 times x minus 24. So if I subtract 460 over here, I would need to distribute this and distribute this, whatever that is, and then distribute in the negative 5, and then bring in the 460, and then refactor it. Not worth my time. Okay? Over here, all we have to do is plug in that formula as written, and then find the zeros. In fact, the first zero is the only one we need. Does that make sense? No, you plug in the formula like this and subtract 460, and then that will drop the graph from the original graph down to here, and this root will be the one you want. You could graph the original and just keep plugging in x's until you get y equals 460. Or you can bring it down to the x-axis and ask the calculator to find the root. No, it's negative 5 times x plus 3 times x minus 24 minus 460. Right, but we want to know where x equals 0. So we're going to subtract 460 from both sides. And now this equals 0, which allows us to graph it. Okay? 81. Approximately how many days will 160 people have contracted the flu? So 81 is the same idea. You have an equation. How long does it take for P to equal 160? Well, just change the equation. The equation right now is negative t squared plus 13t minus 130. So I'm just going to do it in x's. Is that right? Did I write that down right? So I want to know, make up my mind. I want to know, when does this equal 160? Well, let's subtract 160. And I get negative x squared plus 13x minus 30. And I don't like this equation. Why don't I like this equation? The x squared is negative. Can I change that? Yes. As long as all I care about are the roots. This equals 0. If I multiply the entire thing by negative 1, do I change the graph? Yes. But I leave the roots just as they were before. Oh, yeah. So times it by negative 1, and I get x squared minus 13x plus 30. Are there factors of 30 that add to be 13? Is it 10 and 3 or 15 and 2? Why 10 and 3? Because the 30 is positive and the 13 is negative, so they have to have the same sign. They both have to be negative. So x minus 13, 10, and x minus 3. So I get two roots. X equals 10 and 3. Which one is the answer? Why? The domain is listed in the problem as being between 1 and 6. That function only exists between 1 and 6. So that's the answer. Okay. So you're going all the way to 90, what did we say, 97, but you're skipping problem 83. Okay? Yeah. Yeah, skip 83. All right. Good luck.